You also know all these things, but that will be the central thing that I would like, that whatever be the classroom teaching or the experiments in the laboratory, they should not alienate us from this bigger physics laboratory, right? But that happens at many places. That happens. The laws of physics which are in textbook and the laws of physics which are in life appear to be different at certain times. And this kind of disconnect between our science teaching or teaching in general and the life, this makes the task very, very difficult. Because then you are learning, students are learning something which is totally new. Because if they are not able to connect it with the real events, then whatever they are learning is very new. And then things become very, very difficult. So that was one. Then the second thing is, this is because of this connection itself. The balance between theory and experiment. An experiment doesn't mean there's 20 experiments or 10 experiments or 12 experiments prescribed by the board. No. That is different. Those experiments are different. But any concept that we teach, any concept, right? So there are two aspects now. One is theory, which involves equations, mathematics, and many things. Formal structure, definitions, very formal structure, definition. The physics that we see in our life, there this formal structure is not there. We all the time encounter physics just like it's showering from all sides. Right? There is no formal structure. But when we do this syllabus and classroom and all this, so then it is a formal structure. Each word, technical word, has a specific meaning. And unfortunately, there are words which are also used in colloquial sense, and the same words are used in physics in a technical meaning, and then there is always a chance of misinterpreting and confusing that. So that's one part, theory. But the second part is the corresponding event. It is there in nature, but we have to bring it there and connect with this. If I am teaching something, and then I should also, we say that light goes in a straight line. That's okay. A very, very, very simple concept, and it is this thing. But if I can show that light is traveling in a straight line, that will be a very, very effective. Okay. So do you have a laser here? Laser? Any kind of laser? It is in your bag. Okay, very good. And a plain mirror? Plain mirror should be somewhere. Some ladies will have. Okay. Similarly, if you are teaching say refraction, you say that if light falls obliquely on a surface which separates to medium, then it bends at the surface. Now, if I can show that bending, if people can see a light beam coming, falling on say water or somewhere, and then it bends, if the bending is seen, and then you say that okay, this is I, this is R is smaller than I, or R is larger than I, and then you can go ahead, the sin I by sin R is equal to the refracting light mu. That doesn't have, from the nature I do not know that sin I by sin R is equal to mu. Okay? But what is the sin I sin R? What is the sin I sin R? And the ratio, what we are talking. So for that, if I can see a beam coming, then refracting, bending, then I know, okay, this angle is R, this angle is I. Okay, we have to take sign of this angle, incidence angle. So the incidence angle making on the blackboard with calcium carbonate and having an incident ray in terms of electric field and magnetic field are different. But once I have this connection, it is this thing that I am drawing there on the board, then all that geometry will be much more meaningful. Right? And if I don't have this in my mind, and someone says that this is this bends like this, and this eye like that, I will not be able to get a picture of that. And then the connection of physics with our own life will be weak. So that is how it is there.
Water.
ये इस बैटरी ठीक है? So do you use Blackboard?
Yeah.
Then okay. In any classroom, you use blackboards and chalks, and therefore definitely duster also. No, we did a science fair program way back in 2007, and the science it was for school students, class 6 to 9, something like that. And we first had at IIT Kanpur 1 month's training of these students, and then the science fair. So in that 1 month training, our resource persons, our teachers will interact with the children, and there are a lot of children. So we used to 4 different rooms, those training classes used to run. 4 different rooms, packed, no chairs. Everyone is sitting on the floor, and then the teacher is teaching and how they are preparing for that science fair. So some 200 students will be there in one hall, and one teacher, and set 4 places it's going on. So it's a big event. It was a big event.